Hello, this is going to be an install tutorial video for the Joycon RGB kit. Now the PCB and LEDs already come pre-assembled, but you'll need to do the install. It's a little bit complicated. Here's a quick rundown of everything that you're going to need before you get started. You're going to need your Joycon shells. If you're looking for third-party, I recommend Extreme Rate. They use really solid plastic and they're the best I've seen so far. You're going to need your existing Joy-Cons fully disassembled. I recommend taking the board completely out. It's going to look like one of these three options, which we'll go over in just a moment. You'll need your two fully assembled Joycon RGB kits. I'd have a Joycon battery that's charged up for testing purposes, ready to go. You're going to need your buttons that are included with the kit. These are hollowed out specifically for use with the RGBs. You'll need a pair of tweezers. I recommend, but it's not required, some liquid flux. If you have some paste flux, that should be fine as well. Flush cutters. Screwdriver kit, that's for assembling and disassembling. You likely have one of these if you're already taking your Joy-Con apart. Some type of craft blade or razor blade, something with a fine point. Q-tips. Alcohol for cleaning. Toothbrushes, not required but recommended, and then some type of thin plastic spudger tool. You could use a guitar pick if you want. That just helps with disassembly. And something to drink, because this process is not for the faint of heart. Most of this stuff can be obtained at dollar stores, minus like the flux. And I mean, of course, you also need a soldering iron. A multimeter isn't required, but if you're having issues or you're running into weird issues, that could help with troubleshooting, and we'll get into that later. So you'll need your soldering iron, some solder, and then all of the other materials that I've listed. With that being said, let's get into the board variations, and we're going to talk about that just a little bit. So let's go under the microscope, and we'll take a look. So with the right Joy-Con, most boards are going to look like this. It's going to have, if you're looking at the front side, it's just going to be this one big piece with the little connecting bit right here, the thin one. This board I'm demonstrating on is dead, so it's not really going to matter in this case. The work that we do with it, but I'm just going to use it to show you where the different solder points are and what that process looks like. The left Joy-Con board, as far as I know, there are two variations. There's one without a stem up here, and you'll see a lot of vias. This is little gold circles. And then we have the original one, which has the big stem. This had reception issues. It was notorious for having reception issues, and that's why they discontinued this PCB, but there's still a ton of them out there. And I'll show you how to remedy that antenna issue as well. You basically just solder a wire right there, and you'll get a lot of use out of this. So with the different variations out of the way, I want to show you the installation process on the new left PCB, because the process is going to be the same across all three PCBs, just the locations are different. But the theory between each of the three is going to be identical. So now that we have the different PCB variations out of the way, and I hope that kind of demonstrates just kind of how complicated the development of this mod is. Just because you're trying to get one kit to work with both PCBs, that reduces cost. And complexity. Just the install is a little bit different. Now if we look at the PCB here, this part is going to be folded over to the back side, so that way we have access to solder to these pads while these LEDs are installed and in place. If we look here, the labels are not super legible, but good enough. You're going to have L. That stands for latch. This is the signal which tells the microcontroller to turn the LEDs on and off. If the automatic mode is enabled, by default, it's turned off for testing purposes. The V is for voltage, so that's going to be your power from the battery. You have your up, which is going to be your primary button. I recommend wiring this to the minus or the plus button. You have your down, which is going to be your secondary activation button. I recommend using the top button for this. I believe that's either going to be Y or up on the D-pad, depending on if it's the left or right Joy-Con, and ground. It's a little G for ground. That's just your ground wire. So we're going to be soldering 5 wires to each Joy-Con, and the location is going to be a little bit different on each, but the philosophy is going to be the same. The application is going to be the same. It's just the soldering locations, and I'm going to show you kind of how to identify those locations. I will include picture charts in the description, which will show you where to wire each button. And what that will let you do, if you wanted to map it to something else, like you don't want minus, but maybe you want the SL, SR buttons, you could do it. This will work with any of the front-facing buttons, the shoulder buttons, etc. I just did minus and plus, and then a modifier key, just because I thought that would be out of the way. So now that that is out of the way, let's talk about that latch signal. So let me show you on a board where it's already installed. I already have the kit installed. We have this little line right here. This line goes to the analog stick. You can see it goes to this 1, 2, 3, 4, 5. So it's the 5th pin if you're looking at it from this orientation, or the 1st pin, depending on how you want to think about it. This line puts out 1.8 volts whenever the controller is connected through Bluetooth or handheld mode. This is why I use this line out, and that goes to the latch. So that allows me to kind of grab that signal and use it as an indicator to determine whether or not the controller should turn on or off. I've got some double-sided sticky tape underneath, holding that in place. These pads, I just need to say, are very small. There is an enamel coating over the PCB, so you will need to scrape to get to where you're trying to solder to. So if we look here, we have our Joy-Con analog stick connector, and we can see this 1st pin comes out right here. And you can see just how small that point is, at least on this board. If they ever do release new revisions in the future, you should be able to use this same guide. So let me get my wires all in order. I'm going to get those ready to go. I'm going to strip them with the flush cutters, and we're just going to need 5 wires. These wires will be included in your kit. I forgot where I got mine. I believe I got mine on AliExpress. It just came in this huge spool. You could just see all these wires. Just came in this huge spool where it's a bunch of colors. Color coding is going to be really important here. You can pick how you want to color code. I prefer like brown for ground, red for power, yellow for the latch, and then you could do blue and green for the primary and secondary buttons, or the up and down buttons respectively. So I'm going to go ahead and strip some wires, and then we'll be right back, and we're going to solder to each of the boards just like you would for the actual kit. Alright, so I got all my wires, and let's start with that latch signal. So I'm going to get my craft blade. The finer point you can get, the better. And instead of trying to solder to this little tiny spot right here, what I'm going to do is I'm just going to carefully scrape this area. And I'm just using the tip. I just want to expose some of that copper there. And that'll give me a nice spot to solder to. Okay, so that area is going to be nice and ready. We're going to come back to this, and then we will clean it up. Now let's talk about the button inputs. You can refer to the chart for the known button input locations. On this particular board, I want to use the minus button. And the minus button on this particular variation actually comes in right here, and this pin to this little, I think it's a diode or a capacitor. I believe it is a diode. And what we're actually going to do is just solder right here to this little location. So there's no scraping needed there. And there's not really any other good spot to solder to for this particular button input. So we're gonna come back to that. Let's talk about power. Now on this board, this one is different than the others, where the power management IC is located on the rear side. So let's flip that over, and we're going to take a look at this power chip. So this is a battery power management chip, and I just want to explain a little bit of the theory behind it here. Battery power comes in, and this also allows power to come in from the rail so that it can charge from the actual Nintendo Switch itself. Now you'll see this little arrow, and you'll see the dot on the chip. So this is the orientation we want to look at the chip. We're going to see these two pins. Now these two pins, they come out, they go into these vias. This is your power output. This is where you want to get power from. You may think that you're going to just jump and grab power from the battery itself, but that's not what you want to do. If you do that, what's going to happen is when the battery drains below a certain threshold, it might be 2.8 volts or 2.9 volts, the controller power management chip will think that the battery is permanently dead, and it will refuse to charge, and your Joy-Con will be bricked until you disconnect that power line. Now there are some other mods which use this method, and they're inferior for this reason. The fact that if you leave it plugged in for too long, leave it unplugged from the charger for too long, and the battery dies, you got yourself a bricked switch unless you have some way to disconnect that. I've seen some like hodgepodge workarounds for that, for these types of mods, but this modification prevents that entirely, because we're going to be dealing with the power coming out from the power management IC, so it's only going to get power when there's enough charge available. Otherwise this chip will shut it off and protect your Joy-Con. Now in this particular Joy-Con, I've mapped that out. That's going to be this little pad right here. That's where your power is going to come in. So what we're going to do, we're just going to prepare this pad by scuffing it up just a bit. And that's going to be our voltage. That's going to be our power output. So what do we got? We got our power output, we got our latch, we got our two button inputs if you're referring to the diagram. I believe the other one that we are going to want is going to be one of these two pads. Let me just double check. One of these, I'm talking about these small squares, one of these squares will be ground. So I got my meter in continuity mode, so it'll beep when I'm touching ground. Oops. Let me actually change it to continuity mode. And the pad that is not ground should be the one that we're going to be scraping. So I can see that this one is not connecting, so that's going to be the pad that we're going to want to scrape. It's that very small rectangular looking pad. So we're just going to go ahead and scrape it. And this is going to be our down arrow. So the button combination for this, if you were going to scrape that pad, it would be minus plus the down on the D-pad. You know, actually now I'm thinking about it, I think what I would like to do is I'd like to do minus and up on the D-pad. So let me just confirm the location, then we're going to scrape that away. So in this case, our up button is going to be this little guy right here. So I'm going to go ahead and scrape it very carefully. I'm not applying a lot of pressure, just enough to make that pad nice and shiny. Okay. It's okay if you scrape around it a little bit, just be careful not to rip anything. So now that we've got all of our pads scraped, I may want to come back here and just do a little more on that. The last one we're going to need is a ground pad. You can really do, you know, I can see that this, and let me just explain what ground means. Ground just means where the energy, the electrons are all flowing to. It's kind of like a sink. So everything's going to move in the direction of ground, all the current. All of this lettering, this is all ground. It's all part of the ground plane. And I can see that this pad right here is also part of ground. So I'm just going to go ahead and scrape this as well. So now that we have all the locations on the revised left PCB, let's talk about the same thing on the old left PCB. I'll just show you the locations and we'll scrape them. So here's the old left PCB, and I just want to show you the power IC is on the battery side on this one. So let's flip it over so we have our orientation. And remember, the power is coming out from these two pins. This was a board I previously was developing with, so there's already a solder joint there. That's where the power output is going to be. Ignore this mess. This is from previous development, which looks awful. We're going to move our way up. So we have an issue here. There's no diode or capacitor to latch onto, and none of these pads work for the minus button. So what I actually had to do is I had to flip it over, and you can actually see there's a cap right here. The diode is right here. I can see this side's ground, so this is the button side. So what I do is I solder a wire right to here. You can just run it down through this hole, or you could run it down around through this hole, or you could just run it around the side. Doesn't matter, but that's where you're going to be soldering to if you want to use the minus button on this board. And then for the down button, that's going to be this guy right here if you want to use the down button as your secondary. Let me pull up my documentation, and we can see that the up button for us is going to be this big circular pad right here. So that's going to be the one I want to use on this one. So it'll be minus and up, just like the one we just prepared. And then our ground point, I can see right here, this one is connected to this big ground plane. There's that logo I was saying, and see this light green, it's all connected. So I'm just going to scrape this off as well. Okay, so this one's just about ready to go. I mean, I already had this one tinned, but you would scrape that as well. So let's move over to the right Joycon PCB and what the preparation for that will look like. Now for this board, there's not really a pad for the power output. One thing you could do is you could solder directly to this capacitor. The other thing, which I've been favorable to, if you turn the board around, there's this power LED right on the back side here. The full power goes straight there, and it's opened by this transistor. So you can solder a wire right to here and just run it over. You're not going to have any issues that way either. For the sake of demonstration, I'm going to solder it to this capacitor because it'll put more on this side of the board. Now let's talk about that latch. So here is our analog stick connector, and we want that that first pin out, just like we said before. So that's going to be right here. I think I showed you on the demonstration board already, but let me go ahead and scrape this. And then on this one, I am going to want the Y button and the plus button. So the plus button, that's going to be up in the corner. It's going to be this top pad that's surrounded by dark green. I've already scraped that and tinned it. And then your up or your Y button is going to be this small pad right here with a little eyelet sticking out. So if you're looking at this, it's 1, 2. It's the second one down. So we're going to go ahead and scrape that as well. And now your ground is going to be right here. I've already soldered to it, but you're going to scrape that and solder to it. So let's clean these boards off with some IPA. And I'm just going to use the toothbrush. So let me show you. We scraped in some spots. Let me show you on the new board. I'll just show you what this looks like. Because we've already scraped. But we want to clean it off just so there's no debris. Just put some alcohol. I'm using 99% IPA, but 95% should be fine too. You can get it at a local drugstore. I'm just going to clean it off with a toothbrush and some IPA. We're going to do that with all the boards, with all the spots that you scraped. And then we'll be ready to move on to the next step. So let's do that now. Alright, so I've got my wire stripped, and let me just show you what this looks like. I've just got a tiny bit stripped off. This might even be too much. If you do see it's a little too much, you can even just come in and cut some of it off. You barely need anything, just a little bit, just like that. So let's deal with the tinning all of these joints first. What I'm going to do is I'm going to take some liquid flux. I'm just going to put it on each spot, just a tiny drop on each spot where I scraped. It's got our ground. We've got this capacitor, which is going to be our minus. So let me solder to that. We've got our up button, up D-pad. So that's going to go right there. And then we come down here. We got our power. Okay, so those are all good with flux. Now I'm going to come in with some solder. I'm using leaded solder. I'm going to scrape off the tip of my iron. I'm just using a little curved tip. Something fine point will really go a long way here. Let's deal with this latch pin first. Gonna heat the area and come in with the solder. Let's see if I can get this. So you want to take your time. Just a small joint. We got some burnt flux, but that's okay. Let's keep going. Let's do this ground. I'm going to hold my iron. I've got my iron at 385 Celsius. That's great. Let me get my fume extractor coming in. Now let's focus on the up D-pad breakout via. And this one of the tough things about this project is, none of these vias are labeled, so it's all just visual. That's going to be fine. Let's deal with this capacitor. I'm just touching it, so I'm just adding a little bit of fresh solder there. And then let's go down to this power pad. There we go. I'm not going to show the wire installation process on each because you already have the solder points and the theory behind it. and it's going to be the same across each board once you get these wires soldered in place. I'm actually going to come in with a Q-tip and wipe this off. Just put that alcohol down. A little burnt flux is not going to hurt anything. You just don't want to keep holding it there. And this alcohol won't hurt anything either. Okay, that's all looking great. So let's dry this board off, and then we're going to install the wires. So let's start at the top, and we're going to work our way down. So I'm going to add a little more flux to each of these joints. Flux won't hurt anything here. It'll just help. It'll help everything kind of go in place where it needs to. So let's start at the top. I'm going to use orange wire for the Y button. This is where some tweezers are going to come in handy. And I'm going to kind of come in like this. And I'm not going to be grabbing too close, but I just kind of want this to lay right next to it. And then I'm going to come in with the soldering iron. I'm going to heat up that joint. Let's see if I can come down on top of it like this. This can be a little tricky. Oops, I soldered to the wrong spot there. And you'll notice with this wire, the heat will kind of make that tubing around it kind of sink back because it's melting. Let's see, so I just got it down there. Let's hold it for a second. But the nice thing about this tubing is once it melts to a certain point, it's not going to keep shrinking back. So you'll see I've got a little bit of overhang there. And all I'm going to do is I'm just going to come in with my blade, and I'm not going to slice. It's more of a chop. So I'm just going to come down, and a wiggle. Let's see if we can get that up. There we go. Let's see if I can just wiggle that part off. Whoops. Let's try that again. You can really see how how finicky this can be. Let's add some more flux. This is just one of those things you just want to take your time, take it easy. Let's come in with those tweezers one more time. Once your positioning is set, I'm just going to come press this on top. There we go. There we go. That's solid. Let's move on to the next one. So I want to try something a little different here. I think what I'll do is instead of stripping the wire back, I just cut it, and I'm going to come in with my tip. I'm just going to touch it, and that'll expose just enough. So now let me come in. There you go. That's solid. Let's go ahead and do our ground wire. So again, I'm just going to come in and touch it to the iron. Great. And we'll need that latch wire. Oh, I used the wrong color, didn't I? That's okay. I'm just going to use the purple one for the latch, and it won't be a big deal. Let's add some flux. As long as you know what the colors are, they'll be set for success. Yeah, I think that works out better than stripping it, because once that insulation melts back to a certain point, it's no longer going to melt back. Let me come into my tweezers. I want to move it over just a little bit so it's more secure. Great. And now just the power. Let's see. Didn't exactly expose the wire there. Let me trim a little bit back, and we'll try again. I bet when I was stripping it, I pulled the sleeving back a little bit. There we go. I'm going to turn this sideways so I could have the wire coming in like this. Move these other wires out of the way. Don't want to touch that little plastic connector. And that's nice. And I'm showing you on this one because I think this is probably the hardest one to do. The other ones, the other variants of the board are probably a little simpler. But this one, because it has all of those exposed vias, that makes it a little more susceptible to bridging and things like that. Just make sure you use a lot of flux, and don't worry about using too much flux because it'll clean off. And when I'm cleaning off, I'm being gentle. I don't want to tear off any of these wires. I'm going to brush gently. So I'm going to go ahead and do this process on the other boards, then what we're going to focus on next is the shells and what you need to do to the shells to cut those. Because you will need to trim the shells just a bit to fit that kit in there. Okay, so let's do that next.